Okay, good morning. In compliance with the conference schedule. Good morning, everyone. I'm Dr. Firas Shokat Hamid from Northern Technical University, Iraq. It's my pleasure to serve as the session chair for technical session 4D at World System Software Security and Sustainability 2026. We will begin shortly once all presenters have joined. Distinguished guests, respected researchers, ladies and gentlemen, it's my pleasure to welcome you all to Technical Session 4D of the 10th World Conference on Information Communication Systems, Software Security and Sustainability 2026. My name is Dr. Firas Shokat Hamid at Northern Technical University from Iraq, and I'm honored to serve as your session chair today. Today's session brings together a diverse collection of research contributions covering artificial intelligence, machine learning, intelligence automation, robotics, financial technology, healthcare systems, and sustainable digital transformation. These topics reflect not only current scientific challenges, but also demonstrate how interdisciplinary research is shaping the future of our societies. Before we begin, I would like to remind all presenters that each presentation is allocated 15 minutes, 12 minutes for presentation and 3 minutes for discussion and questions. I kindly ask all presenters to keep within the allocated time so that every researcher every researcher has an equal opportunity to present and interact with the audience. I also encourage everyone to actively participate during the discussion sessions by asking constructive and insightful questions. Without further delay, let us begin today's technical session. Thank you. It's now my pleasure to invite our presenter, Dr. Fabian Nasrullah, who will present the paper entitled Analysis of Financial Literacy, Perceived Risk, and Financial
Hello,
Self-Efficiency on Akolaco and Credivo
hello,
Attention and Actual Usage among Generation Z in Indonesia. Please proceed.
hello. Thank you, sir. Um, Hello, everyone, and a very good afternoon. Dear authors, session chairs, and invited guests, welcome to Technical Session 4D. Myself, Samruddhi Mogal, and I will be the moderator for this session. On behalf of Global Knowledge Research Foundation and Geoscholastic, it is my great pleasure to welcome you to the 10th World Conference on Information Communication System, Software Security, and Sustainability. London, UK. And the 10th edition of the conference is being organized in a hybrid mode. The physical event was successfully held yesterday in London, UK, and the virtual event is being conducted through Zoom from 29th to 30 July 2026. I hope you all enjoy today's informative, insightful, and interactive technical session. In this session, we have six paper presentations. Each presenter will be allotted 12 minutes for the presentation, followed by 3 minutes for the question and answer session. I will give a gentle reminder when 10 minutes have elapsed to help you manage your time. I would also like you to request all participants to kindly stay connected with us until the closing remarks for this session. If you have any queries and require any assistance during the session, please feel free to write to me in the chat box. Before we begin to the presentation, I would like to introduce the distinguished session chair for this technical session. Today we have Dr. Firas Shaukat Hamid. Dr. Firas Shaukat Hamid is an assistant professor at the Northern Technical University, Iraq, with over 28 years of academic and professional experience in computer engineering. His core research interests encompasses computer networks, mobile communication, telemedicine system, and 5G technology. I may now request our respective session chair to kindly share a few words, offer their valuable insights, and guide the presenters before we begin today's technical session.
Okay, I told about to invite about our presenter, Dr. Faberian Nasrallah, who will present the paper entitled Analysis of Financial Literacy, Perceived Risk and Financial Self-Efficacy on Akolaco and Credivo Intention and Actual Usage among Generation Z in Indonesia. Please proceed.
Okay, thank you, Professor. Let me share screen first.
Sorry to interrupt. We do have another session chair today. So let me introduce our second session chair for today's meeting conference. We do have second session chair Dr. R.K. Taylor. Dr. R.K. Taylor is the professor and director at Chhatrapati Shahu Institute of Business Education and Research, Maharashtra, India, with over 20 years of teaching and research experience. A renowned expert in robotic process automation and accounting, he has authored more than 50 books in the fields of commerce management and technology. He also holds over 10 national and international patents related to the application and adoption of RPA across various business and commercial sectors. I now request our respective session chair, Dr. R.K. Taylor, sir, to share a few words with us.
Thank you so much, Samruddhi, and thank you so much, especially for inviting me and giving the responsibility to chairing this session. I really welcome. I'm also welcome all to my my co-session chair, Professor Firaz, and all the paper presenters who are presenting their papers on the different theme of this information communication system. This everybody is known about that present scenario is changing very fastly, and we need to learn many things for the updation of our technical system. Majorly, everybody is focusing for the sustainable development goal, and information technology is playing an important role while we are talking about the software development, communication development, or security development. Presently, there are two important factors which we need to address in every research, that is privacy and security of the data. That is a major issue. And when we are dealing with all these aspects, we can find out globally that there are a lot of issues in managing the data, managing the security and the transparency. So these type of security and transparency, if we could manage, we can really help the social perspective of in the businesses or individual also. I wish all the paper presenters best of luck, and I request to all of you that please be about in the time being, do not focus about the introduction or anything, just focus your objective research and your conclusions. So my wishes are to all of you all the very best, and be specific on the time, which has already been mentioned by Samruddhi, the session handler, and Dr. Firaz. Thank you so much, Samruddhi.
Thank you so much, sir, for your valuable words.
Now I think you need to start with, and the first paper presenter will speak, right?
Yes. Now let us begin with today's paper presentation. I would like to invite Fabian Nasrullah, and their paper title is Analysis of Financial Literacy, Perceived Risk and Financial Self-Efficiency on Akulaku and Kedrivo Intention and Actual Usage among Generation Z in Indonesia.
Okay, thank you. Let me share screen. Okay. Is there any screen?
Yeah, it is visible with us. You could continue.
Okay, thank you. First, maybe good morning, distinguished professor, respect judge, ladies and gentlemen. My name is Febriana Sula, and I'm write this paper with my co-author Abdul Mukti Soma, and it's my pleasure to present our research entitled Analysis of Financial Literacy, Perceived Risk, and Financial Self-Efficacy on Aku and Credit for Intention and Actual Usage in Indonesia. BNPL usage among Generation Z in Indonesia. Okay, for the next one. The rapid growth of financial technology has significantly changed how people access credit. Among various innovations, buy now pay later has become one of the most popular payment methods because it enables consumers to purchase products immediately and pay later through installment. Generation Z represents the large group of digital financial service users in Indonesia. However, limited financial experience may expose them to impulsive spending and excessive debt. So, what is core research in the study is focused on three independent variables. For the first, financial literacy, which reflects an individual understanding of financial concept and responsible financial decision. For the second, perceived risk referring to concern regarding financial loss, privacy, and repayment obligation. And the third, financial self-efficacy, which represent an individual confidence in managing personal finance. These variables are expected to influence both the intention to use buy now pay later and actual usage behavior. Okay, for the next research methodology, what I use is this research employ an explanatory quantitative approach. Data were collected using an online questionnaire distributed to Generation Z respondent in Indonesia who had used Akulaku or Kredivo application. And total of response is 385 valid were obtained. The data were analyzed using structural equation modeling with partial least square or SAMPLS through Smart WS4. So, the result is the direct effect analysis indicates that most proposed relationships are statistically significant. Financial literacy and financial self-efficacy positively influence both intention and actual usage behavior. In contrast, perceived risk negatively affect users' willingness to adopt buy now pay later service. These findings demonstrate that both financial knowledge and confidence are essential in encouraging responsible digital credit usage. Okay, for the result indirect effect or mediation, the mediation analysis revealed that intention plays an important mediating role. Financial literacy, perceived risk, and financial self-efficacy influence actual usage not only directly, but also indirectly through behavioral intention. This complementary partial mediation suggests that users first develop an intention before deciding to use buy now pay later service. So, the model explanatory power or R2, the model demonstrates strong explanatory capability. Approximately 73.4% of the variation in actual BNPL usage behavior can be explained by the variable included in this research. This indicates that the proposed research model effectively explains Generation Z's buy now pay later usage behavior. So, what's key funding and discussion about Malas paper is these are three important findings. For the first, better financial literacy and stronger financial self-efficacy and correct responsible buy now pay later adoption. And the second one, perceived risk remains a major barrier to using digital credit service. So, for the last, final intention act as the bridge connecting financial and psychological factor with actual usage behavior. So, the conclusion is financial literacy, perceived risk, and financial self-efficacy significantly influence buy now pay later usage among Generation Z in Indonesia. Improving financial education and increasing awareness of financial risk are essential to encourage responsible use of digital credit and reduce potential financial problem in the future. Okay, That concludes my presentation. We hope that this research contributes to a better understanding of digital financial behavior among Generation Z and provides valuable insight for fintech provider, policymaker, and future researchers. Thank you very much for your attention.
Thank you very much for your interesting presentation, for this insightful work. Now we wait about the questions.
Fabrian, you had work on the thing about your PLSM, right? And
All
you've
right.
taken the data of 385 respondents. Can you please
Yes.
explain me which method you have applied for the research?
For my future research?
Yeah. No, no, not
Okay.
like research. Means which type of method you have used for your research.
Oh,
That's
for different uh maybe for different research is for target is maybe not only from Indonesian maybe.
okay.
Maybe we can take in different country because I never known what is different in my country and different country because binocular is new in this year is new in Indonesian is so many people take this binocular because this make viral in this Indonesian. So that's why I'm take this research. So for the future research, maybe I think you must take the different country maybe.
Okay, and why you have taken only 385 respondents?
Yes.
You have taken 385 respondents for your present research, right?
Wait. My speaker is too small for the volume.
No, no, no. I'm just telling you, you have taken 385 respondents, right?
Yes, right.
So what is the base behind 385 only?
For the base in 385 respondent is whose people who before 6 months of they are use binocular is 6 months later or 6 months after this
Okay.
month. So I take 385 respondents is because they are what is they are there there are maybe once to use binocular for 385 maybe once.
Okay. Okay, fine. Thank you. Done with me.
Okay.
Yeah. Proceed with others. Other speakers, if they have any question, they can ask.
Okay, what?
Anyone, if have any questions, they can ask. Professor Firas, if you have any question with him, you can ask.
No, I don't have a question. Thank you once again. We now move to our next presentation,
I think
complaints
Simon,
about
you
the
have
conference schedule.
yeah. So
Our pleasure to invite next presentation Dr. Byron Albuja, who will present the paper entitled "The Comparative Assessment of Large Language Models (LLM) for PID Tuning of a Third-Order Cruise Control System Without Expert Feedback." Please proceed.
Good morning, everyone. Please allow me to share my screen. Good. Good morning, everyone. I will present the results of the paper entitled Comparative Assessment of Large Language Models for PID Tuning of a Third-Order Cruise Control System Without Expert Feedback, written by Miguel Lema, Luis Ortiz, and my person, Byron Albuja. As an introduction, large language models represent an evolution in human-machine interaction. Instead of replacing human expertise, they augment it by combining adaptive reasoning with natural language interfaces capable of translating design objectives into quantitative control actions. The purpose of this study was to evaluate the performance of different chatbots in tuning a PID controller for a given transfer function, focusing on the methodology they follow to achieve the desired performance parameters. Chatbots received the following prompt: the transfer function for a linearized approximation of a 1.5 tons vehicle traveling at 30 kilometers per hour. The performance objectives for the PID controller were overshoot not greater than 5 kilometers per hour and settling time of 8,33 seconds. All of this for a set point of 45 kilometers per hour. The vehicle's transfer function is shown at the end of the slide. The 5 chosen large language models chatbots were GPT 5.3 model generation, Gemini 3 Flash, GenSpark, DeepSeek version 3.2, and Mistral. It is important to emphasize that only the free user access version of every chatbot was used to perform the PID tuning task in order to maintain an even playing field for every chatbot. No further instructions were given, such as tuning methodology, the test chatbot capabilities to assure the achievement of performance objectives given on the prompt without expert feedback. The chosen transfer function is a stable tier order system with a steady-state error. Pradhan et al. Designed a PID controller for the cruise control system using an line optimizer algorithm, which was used to compare the performance of the chatbot's design. The only feedback each chatbot received was the tested performance of its controller to test if they would try to amend the errors by their own. This chart resumes the design process done by the chatbots. First important observation, all of them use the pole placement methodology for the tuning process. This shows that they prefer classic control theory to address the given task. As the design objectives were overshoot and setting time, all chatbots decided to calculate the dominant poles for a second-order system that would achieve those characteristics. GenSpark improved the initial design using Nelder-Mead optimization algorithm, and DeepSeek and Mistral with the Siegel-Nichols method. During this initial design, DeepSeek proposed 4 different controllers, and Mistral 2. The other chatbots only showed one controller as result. Even though the prompt clearly asked for a detailed explanation of the tuning process, DeepSeek did not specify the parameters it used for the pole placement methodology, nor the non-dominant poles it chose. GPT, Gemini, and GenSpark use practically the same parameters for the designing of the 2 non-dominant poles. On the other hand, Mistral used different values for the damping ratio and the nitrile frequency, as it used the 2% criterion for the settling time instead of the 5% criterion used by the other chatbots. With a tier order system, after the addition of the PID controller, the resulting system is a 4 order. So the design process required the addition of 2 non-dominant poles, which only GPT and GenSpark specified. The other 3 chatbots didn't specify the non-dominant poles used for their design. GPT and GenSpark returned the most detailed explanations for the tuning process in comparison with the other chatbots. GPT was the only chatbot that did not attempt to redesign the PID controller after it received feedback about the actual behavior of the design. And GenSpark was not able to attempt a redesign as the free credits ran out. On the other hand, Gemini, DeepSeek, and Mistral executed a redesign attempt using heuristic methodology. From all the chatbots, DeepSeek offered the best explanation for the tuning process using the heuristic methodology. The following image shows the performance of the best controller designed by GPT, GenSpark, and DeepSeek, in comparison to the benchmark controller proposed by Pradham et al. The design's goals given on the prompt were an overshoot not greater than 11.11% and a setting time not greater than 8.3 seconds. All of these measured using the 5% criterion at a set point of 45 km per hour. The controllers proposed at Pradham, shown in the blue line, achieved 4.5% of overshoot and 3 seconds of settling time. Followed really closely by the GenSpark results in the black line, with a 15% of overshoot and 12.35 seconds of settling time. The controller proposed by GPT on the green line and DeepSeek on the purple line didn't achieve the proposed goals. As we can see, the overshoot is the greater on GPT with 38% and 22% with DeepSeek. On the settling time, GPT managed to stay within the goals with 7.9 seconds of settling time. However, DeepSeek showed the greatest settling time with 25 seconds. From these chapters, we can see the results of the last two large language models. These two show the best results obtained from the chatbots. From the point of view of the vehicle's passengers, the performance of these three controllers will be difficult to differentiate as the overshoots are not so different. And the setting times, the PID designed by chatbots, are a little bit slower than the PID proposed by Pradham et al. In the comparison, we can see that the overshoot percentage for Gemini in the green line and Mistral on the black line are not so high. They are keeping the results within the goals. 8.8% for Gemini and 6.6% for Mistral. The settling time was a little bit higher than the goal proposed, but we can consider that the users of the cruise control system of a vehicle will not notice any different performance from all of these PID, as the settling times won't be so great in difference, and the overshoots will be very low. In conclusion, large language models, chatbots in their free versions, show a good knowledge of classic control theory. All of them engaged the control task by fault placement methodology. None of the AI-generated controllers outperforms the one proposed by Pradham et al. This is attributed to the following facts. No expert feedback was given to them to fix the observed flaws in the proposed design. No specific methodologies were asked to be used in order to improve the result. And no specific instruction to redesign the controllers were given to chatbots in order to test their disposition to fix their errors without the user specifically asking for it. None of the chatbots performed not proposed robustness or sensitivity tests on the designed controllers. So it is important to always validate AI results as they cannot be trusted blindly. Research suggests that large language models can assist in preliminary controller designing tasks, although their effectiveness remains limited without expert-guided interaction. Explicit optimization-oriented prompting, robustness testing, and resource validation. AI chatbots tested on this study show a good level of understanding of basic control theory. They offer good explanation for the tuning process, and the performance of tuning with heuristic methodology is really high. For future work, we plan to test the large language model chatbots in the use of optimization algorithms to improve the performance of the designed PID controllers. We propose to document the capabilities of large language model chatbots in the execution of sensibility and robustness analysis for PID controllers, and to expand the study to test the large language model chatbot's limitation to analyze control effort and phase and gain margins. Thank you for your time.
Thank you for
Thank you very
presentation.
much. Thank
Do
you
we
very much
have
for
any
your interesting
questions from
presentation. Congratulations on
yes?
this valuable contribution. While we wait for questions from the audience, I would like to ask about, do you think expert feedback could further improve the proposed framework?
Of course, expert feedback is really valuable while interacting with large language model chatbots because they always need some feedback specifically to achieve the design goals. As we saw in the results, it was very difficult for every chatbot to accomplish the design goals. So they always are in need of feedback to improve their results.
Okay, thank you. Dr. Taylor,
Thank you.
do you have any question?
Yeah, thank you so much. Baron, one thing I just want to ask with you, your study is really remarkable and it is really good indeed for the scholars who those are applying the chat GPT and other tools for their research, right? But I just want to ask one practical application on your work. What is the major limitation which you have of identified while doing this study?
One of the limitations was the free credit users limit. As we mentioned previously, we had really a lot of problems with Kenspark as the free credits are really low. Other problems that one could face is that under free versions, the chatbots will not attempt to produce any simulation results or graphical results, so it is very difficult to evaluate the performance of the controllers just by the interaction you have with the chatbot. It is always needed to simulate the results to validate all the information the chatbot was giving.
Okay, okay. Thank you so much. Done from my side. I hand it over to the operator.
Thank you. Thank you. Uh,
Okay, thank you once again.
our next presenter is Aviral Sharma, and the paper title is Enhanced Performance Model for Diabetes Detection Using Machine Learning Techniques. You may start your presentation. Hello. Do we have Aviral Sharma?
Am I audible, ma'am?
Yes, yes, you are. You can start your presentation.
Hello.
Aviral, you can start your presentation.
Okay, sir. Okay. Good afternoon, everyone. My name is Aviral Sharma, and today I'll be presenting our paper, Enhanced Performance Model for Diabetes Detection Using Machine Learning Techniques. So, in short, we built a neural network that can detect diabetes using simple clinical data. So, let me quickly explain what this paper is about. Diabetes is a disease that causes a loss to people's health and to the country's economy. There are also a lot of wrong ideas about it. So our goal was to build a machine learning model that looks a person's health details and lifestyle to detect diabetes. We tested it on PIMA Indian dataset, which has 8 health features per person. And the model we built is a neural network trained using two methods, back propagation and feed forward. Here is what I'll cover today: why diabetes detection matters, what other researchers have done before, our proposed methodology, the data set we used, results, and finally the conclusion. So first of all, what is diabetes? It is a disease where the body has too much sugar in the blood because insulin isn't working properly. If it is not managed, it can damage the eyes, kidneys, nerves, heart, and blood vessels. There are generally different types, the type 1, type 2, gestational, and some rarer types also. Our paper focuses on detecting the more common, that is type 2 style diabetes. So what was our motivation behind using machine learning for this? There were majorly three reasons. First, the medical data is scattered across many places. There is no single system that holds it all. Second, doctors diagnosing manually takes time and diabetes needs constant monitoring. Third, machine learning can find patterns in large health data sets that a person might miss. So our goal was simple: to build a neural network that can accurately tell if someone is diabetic or not, using only 8 basic health features, and where we achieve 93.5% accuracy. So before building our model, we looked at what other researchers had done before. So this was all considering the same data they used. So it went from 76% all the way up to 93.2%. Our model shown at the bottom, that is that reached 93.5%, slightly better than the best previous result that was 93.2. So here's how our system works. First, we take the training data, that is the PIMA dataset. Second, we feed it into our neural network classifier. Third, we test it using separate test data. Fourth, we check how well the trained model performs on the test data. And finally, we get the result whether the person is diabetic or not. This is called supervised learning because we already know the correct answer while training, and we use that to check how well that model learns. So now let's talk about dataset. It comes from the UCI machine learning repository, which includes the health records of 768 people. Out of those, 500 are non-diabetic and 268 are diabetic. So each person in the dataset has 8 health features. That is number of pregnancies, glucose level, blood pressure, skin thickness, insulin level, BMI, a diabetes pedigree score, and age. Based on these 8 values, the model predicts one of the two outcomes: 0 for non-diabetic and 1 for diabetic. Next, we split the data, 60% for training the model and 40% for testing it. That is 460 people for training and 307 people for testing. This split is a standard practice and it helps the model learn well without overfitting or underfitting. Now let's look at the structure of our neural network. It has 8 input neurons, one for each feature. Then it has 2 hidden layers that process information, and finally 2 output neurons which give the final results. The connections between these layers have weights, and the network adjusts these weights as it learns. So as we talked before, there are 2 types of neural networks we talk about here. First is feed forward neural network, which passes the information in one direction from input to output with no feedback. But our model uses back propagation, which means it looks at its mistakes and sends the error backward through the network to improve itself. This is what allows it to learn complex patterns. Here's a simple summary of how the training works. First, the network starts with random values, then it makes a prediction, then it compares that prediction to the real answer and calculates the error. It sends that error backward to update its internal values, and it repeats this process again and again and again and again until the error becomes a very small, negligible number. Now to summarize the final setup, our model has 8 input neurons, 8 hidden neurons, and 2 output neurons. It was trained using something called scaled conjugate gradient with a learning rate of 0.03 for 41 training rounds. This is the confusion matrix, or we can say the results. Out of 307 test cases, our model correctly classified 287 of them. That is an overall accuracy of 93.5%. It correctly identified 222 diabetic cases and 65 non-diabetic cases with only 20 mistakes in total. Looking more closely, our model had 94.1% precision and for detecting diabetes and 82.3% specificity. And if we compare our result to other studies using same dataset, you can see our model on the right performs the best at 93.5%. To conclude, our neural network model can detect diabetes with high accuracy just using basic health data. It made very few mistakes and performed better than the most previous models on the same dataset. Now going forward, we'd like to test this on larger datasets, try deep learning methods, and explore feature selection to make it even more accurate and help the healthcare department from our side. Thank you very much, and thank you so much, sir. Thank you, everyone.
Thank you for presentation. Do we have any questions from session chairs?
No, I don't have any questions from him. Abhinay, it's a nice presentation and really work is good.
Thank you so
Thank
much,
you
sir.
very much for your interesting presentation. This is timely contribution. I would like to ask about how could your model to validate it in a real clinical environments?
So, sir, to implement this in real environment, uh, I would like to try it with more deep learning methods and try with the larger data sets. So, like if I get the hospital patient data and I'll do the all the pre-processing of the data and extract these 8 features from that data set, and then I will try to train that in our neural network model. And if somehow that doesn't work, then I will try some more deep learning methods and try to minimize the error, the maximum I can do.
Okay, thank you very much.
Thank you, sir. Our next presenter is Nallappa Gari Venkata Rami Reddy with the paper IWOF Intelligent Workday Orchestration Framework for Autonomous Business Process Automation. You can start your presentation.
Good morning and good afternoon. First of all, thank you very much for giving me this opportunity. Let me share my screen. Yeah, hope able to see my screen. Yeah. So, yeah. So coming to my presentation here, so it's kind of, intelligent workday orchestration framework for autonomous business process automation. So, so how much a big uh, thing to manage the like kind of so HR more kind of uh, everything like in the organization, like if you want to manage the system to automate these all things, like any kind of approvals in enterprise levels, it will be very difficult to manage all the things. The existing, we do have some kind of existing systems, but it's not completely automation. The problem here, the why rule-based workday automation runs out of road at this moment. Every enterprise is now running on HR, payroll, and procurement, as well as finance, and kind of cloud platforms like Workday and Oracle things. But most of the process still need human in the loop for exception, kind of handling approvals, routings, and resource alignments, kind of that. So that's where our I mean our research comes into the picture, and we we do have kind of some research. uh, Somehow I'm not moving to the next slide. Yeah. So if you see here, so we do have kind of existing system with the result rules can't adapt. So functions are siloed. It's not sequencing, resourcing, and decisions handled separately. So for sure, for each and every process, we need a manual supervision. Remains it's very heavy and very poor resource allocation drives cost and delay. So who cares that? In our, coming to audience perspective, it doesn't, right? So we have to give proper system. Yeah. So here, so what we did here, the three prior directions, like so we do have kind of existing systems we already have to manage these all things, but it's not a complete automation. Some manual interruption would be required to execute all these things. So if I go for first one, you know, we already have that, but it is kind of specific domain, kind of manufacturing only it can give. If we go to the next one, it also kind of very particular organizations only it gives that. So now our model here, so we proposing IWOF architecture. So that means so we do have kind of PIL pull structure out of raw process data and powered by the AWI algorithm sequence of steps, and so assign resources dynamically and powered issues predictive. We can predict the issues and autonomous decisions in an enterprise level. So this is a pipeline, not kind of four independent tools. So it automatically data flows to the left to right. So all sequence of steps doing together here. So moving to the next slide, this algorithm AWIO, autonomous workflow intelligent optimization, works like it's a kind of sequencing engine. So it extracts activities, score duration, and combine into a activity intelligence score, and it estimates the bottleneck probability, then rank into the optimized workflow execution repository. If you see that kind of the formulas we tuned internally, so it like I cannot show here, but yeah, we tuned internally. It's a kind of sensitive information, but yeah, in our model we tuned this alpha, beta, gamma values inside. It works like, yeah. So going to the next one, so it's a raw process from optimized sequence. If you see here, business process data, it extract activities and score, compute, and whatnot. It kind of sequence of steps. So moving to the algorithm two here, it takes optimized workflow repository as an input, forecast whether it will complete on time or not. So it matches the resources by competency, estimate automation feasibility, score the decision, confidence from the history. It compares with history and aggregate that value. So yeah. So from resources autonomous decisions, why what it means. So in the enterprise level resources, it matches the skill, it predicts that, and it matches the score. Yeah. And yeah, if you see this slide, it is comparing with existing legacy systems, our model is kind of, so it gives like 96% of accuracy without manual interruption. We tested this in our test environment. It is working as expected. So we are looking for the kind of, so looking for the opportunity to demo in our kind of model how it works to the environments, enterprise environments, most probably ERPs, enterprise resource planning. So same. If you see here, there is AWIO and Pardo kind of, so if we compare this, we are getting 96.5 accuracy here. That means, so we are eliminating the manual effort. We are kind of, automating the things. Now, just imagine if you have a kind of, 1 lakh employees of organization, how difficult to manage all these HR processes and kind of hires or terminations or any kind of business process transactions. It would be very difficult to manage manually. So we do have kind of some limitations with our model. So to be honest, limitations lead the overhead out scale and not completed large scale industries deployment yet. So so federated reinforcement learning for the weighting coefficients, distributed architecture, explainable AI nowadays, and digital twins. You know, uh, yeah. So, but we are working on our limitations at this moment. Yeah, we definitely tune our model, and we can come up with better thing what we have now. And so finally, so conclusion is, so process automation accuracy is kind of 98.7%, and workflow completion rate is 98.2%. Resource utilization efficiency is 97.1%, and ABP as is kind of 98.9%. Yeah, that's it from me. So thanks the committee, and thanks for giving me the opportunity. Thank you.
Thank you for presentation. Do we have any questions from session chairs?
No, I don't have any question. That's good.
Thank you.
Thank you very much for your presentation. I would like to ask you about the security challenge. Do you anticipate in autonomous workflow orchestration?
Yes, we do have security challenges, but we do have a methodology to protect that security. So in Workday, we have kind of domain security policies, business security policies. Based on that security policies, we restrict the data, and we based on the roles, user-based roles or role-based roles, we provide the users, and we secure the model.
Okay, thank you.
Thank you.
Thank you, sir. Thank you, Venkat. Let's move towards our next presentation. Our next presenter is
Samriddhi, I think Simon had raised his hand. You want to ask something?
Yeah, if the
yes.
possibility is still there, I would like to ask a question. Thank you for realizing my hand. Thanks for the presentation. My question, I think I didn't got it fully, but what was the data about? Was it a synthetic data set or was it a real data set? And I didn't get any idea of the features actually. So I didn't understand the data set with its features. So I was not able to follow actually the approach. This was my problem. So can you just give some few sentences where the data come from, how it looks like, what are the features, so that I can get an idea of what you actually did?
So we request the paper presenter to please explain the queries.
Is it to me, Simon, or
Yeah.
or previous one?
Yes, the presenter just presented.
Oh, okay. You mean Workday orchestration? The question towards Workday orchestration?
But the question was about the data. I didn't get how the data looks like. Was it synthetically generated or was it a real data set? And I didn't get the features of
It's
the data, so I was not able to
no,
follow the approach. This was my
yeah,
problem.
it's a real data, So let's suppose we have an organization. So we are having 10,000 of employees, So maintaining 10,000 of employees like hire data or termination data or leave data or learning data. No, it's a kind of, very big task for the organization to manually approve all these tasks. So we do have kind of existing automation tools, but that is not as accurate, So we have to acquire for each different task one tool. But our model is, so all sequence of steps we are doing together in the same tool to automate
Okay,
the main goal of our model is to automate the things. Let's suppose you want to hire the employee. Okay, no need of any manual interruption or any manual effort. It kind of sequence of steps, business process sequence of steps automatically. When employee applies online, it comes to that. It is a data for us. It automatically evaluate all the resume and experience and his kind of, or what exactly we are looking for that job profile. So once we
so
yeah,
sorry, I think I got that part. But the data set you used to evaluate, was it from a real company or was it synthetically generated?
no, it is
Because you showed
statically
us like,
generated at this moment.
okay, okay.
Yeah,
So, and okay, um,
we do have kind of some test data. Yeah,
okay. Thank you very much.
thank you.
Thank you, Venkat, for
Thank
explaining
you.
Yeah,
twice.
thank you.
Thank you. Thank you, Simon. Thank you, Venkat. Let's move towards our next presenter. Our next presenter is Abir Tag, and his paper title is Remedy, an autonomous mobile medication dispensing robot for elderly care. You may start your presentation.
Hello everyone, this is Abir Taj and I will be sharing my screen now. Okay, can you hear me? Okay,
Yes, you can start your presentation.
okay,
We request you to please focus on your research instead of the introductory part.
okay. So actually, our project is because many elderlies they forget to take the medicine or to take the correct doses on the correct time. So this leads to like problems and health risks. Okay, so our project is actually a robot. This robot, its objective is that we have to make it an accurate pill dispensing, patient authentication. It will have autonomous navigation to the patient and save and organized storage. I will show you in details all the objectives, how we implemented in our project. So here, Remedy, actually it has a dispenser where I will show you here in pictures. We have first the workflow. Okay, we developed a software or an application. This application it has two options or two roles. One role is for the caregiver. The caregiver will first it will ask if you have an account or no. If no, it will create an account and do the login, and then it will add the patient. Let's say I'm the father and I have some patients in my house. I will add the patient name, the patient bills, everything. And the role of the patient, once he open the application, it will send to his mobile a code. He will enter if it's valid. Then it will show him the time remaining for the next dose. Okay. And then also it will show him the medication list. And then for the caregiver, actually, he will take pictures or like let's say like the iPhone when we want to open our phone, we do the face recognition. Same thing, we will do it in our application. The caregiver will take pictures of the patient from all the sides. Then when the patient comes to open the application, it will check if it's the correct patient or not. And then it will dispense the correct pills. Okay. I will show you, this is actually the high level architecture we used for the input and sensors. We have the LiDAR to detect the walls, like it's actually for, like, let's say it will do the mapping, okay, of the room or anything. And then we have this camera, I will show you later. This camera will verify how many pills are correctly dispensed. And here we have the mobile app. They are all connected to the Raspberry Pi. The Raspberry Pi actually, it's like the brain. It will control everything. The Raspberry Pi is also connected to the TurtleBot. This is our robot structure. It has like some motors here, or like wheels to move the robot. And here actually, as you can see, these are the dispensing subsystem. We developed like a prototype, 3D printed cylinders. These cylinders, actually, let's say this is for Panadol, this is for aspirin, this is for any medication. Each one is connected to a driver. This driver, it will rotate to dispense the correct number of pills. Okay. And it's also connected to the drivers here, and we have the batteries. And here are our components, as you can see in clear picture. This is how the circuit that we made. These are the motors, and it's connected to the drivers. Here, the drivers, and it's connected to the OpenCR and the Raspberry Pi. Here is the software system. The software system, as I explained, we have the caregiver mode, the patient mode, and everything is actually, we did a local database, Broom and SQLite, where any logs, any face embeddings and face recognition, it will be saved in this data. Okay. And when like the patient want to open, it will already have the pictures, it will already be in the SQLite, okay, saved there. So when the new patient want to like open the application, it will compare it with the already registered. Okay. And here, as I explained, okay, this is the software design. This is if you are the patient, if you are the caregiver. Okay, here you input the username and password. This is the caregiver dashboard. I told you, if we want to add patient, we just add as many patients as we want. Here is the caregiver will input all of these things. He will input, let's say, set the face. This face is actually for the patient. We will enter the patient name, the age, the email, and which room the robot should go. Is it the bedroom? Is it the kitchen? Whatever, it will be selected here. Okay? And then we input the add schedule as we're adding the medication. Let's say medication 1, medication 2, and 3. 1 for cylinder 1, 2 cylinder 2, and 3 cylinder 3. Okay? Here, let's say the number of bells. I want 2 bells from, let's say, Panadol. So it will dispense only 2. And I select the correct time. I want, let's say, at 3 o'clock, this date. Okay? So the robot, it will come on this schedule only. These are the software that we used. The OpenTo, the Python, the Android for the application, and the Flask and the Twilio. For example, all of these things, we used it. Here this is the robot actually, as you can see here. It has many layers because we want it to be reachable to the patient. Okay, and these are the cylinders where it will dispense the medication. Here is the final look of the robot, and testing and evaluation. I will skip this part and show you actually how let's say I am here, I'm this patient, okay, and it's time for the medication. So the robot will come to me there. Here. It will come and dispense. First, it will see my face. If this is my face, then it will dispense the correct pills. As you can see here, it reaches here and it opens the application. The application will see my face. If it's the correct patient, then it says, okay, you are the correct patient. So it will dispense the pill. And here, as you can see, this is how it dispenses the pill. And for the future work, we want to improve the navigation, enhance the battery life, add voice and language support, and include refill reminders. Thank you.
Thank you, Abhi. Do we have questions from session chairs?
Dr. Firas, if you have any questions, huh? I don't have any
For me, I don't have any question. It's interesting presentation, and we thanks about sharing your search with us. Thank you.
Thank you so much.
Next presenter, please.
Thank you, Abhi. Thank you, sir. Let's move towards our next presentation. Our next presenter is Simon Clocker, and the paper title is WhatsApp, a RAG, a powered WhatsApp chatbot for supporting rural African clean water access, sanitation, and hygiene. You may start your presentation. Simon, your mic is off.
Thank you. Otherwise, you would have listened like 15 minutes to silence. Thanks for the possibility to present our work, our joint work together with two friends from Uganda. What I've learned today is that I will rename my paper next time with an A at the beginning, so I will be the first in the session, not the last one, this W here. Before we go into details of this title, I will just start with the motivation. I think this will make much more clear what this long title is actually about. So, the problem context. So we want to make the world better. There are these SDGs, Sustainable Development Goals, which are measuring this impact, and SDG 6 is measuring like clean water access, and it's still a problem. This is not a surprise, I guess, not to anybody, and it's still a problem in Uganda, which was once again shown in the last census, which showed like that in some areas up to 60% there don't have even a toilet. Yeah, so the problem is real. That's the setting we want to work in. And we thought about how can we target this problem of clean water access or knowledge about clean water access. And we thought, can digital health education help? Yes or no? There is evidence around that it might help. So we have evidence that digital education at all can improve clean water access. We have evidence which shows that people who use their smartphone for information seeking for this topic improve their clean water access. We have already 2 or more chatbots around, mostly from India, which could show that like chatbot-based digital help can improve this situation. So this was easy to come onto idea to try the same thing in Uganda, but we want to build up on this previous work and think of what was not good in previous work, which can we enhance. And what was shown in previous apps that try to address this wash-related issues is that it was app-based. Yeah, so there is this hurdle. I always must install a new app from the App Store. And the second one is that the information that was given, it was basically decision tree based, so it was limited in its context awareness. And we are now in a lucky position that large language models are freely available all over the world. So we said, okay, let's give it a try. How can we create a low-cost solution in an area which is obviously underserved with digital health apps, yeah, that can make a real difference. So what is new? The context is unique, so it was not done in the context before. The architecture which we suggest is not rocket science, but it's new in this specific context, so that we want to use a large language model with RAG architecture in the background to contextualize. And I think our most important contribution is that we try a new channel. So we don't do this thing with an app, which people must install, but we use WhatsApp as the channel to bring our content to the consumer. So these are basically two differentiators of this paper. And this comes to the central evaluation question. When we try to build an artifact like this, which supports education in WASH-related issues with a RAG-based architecture, is the quality enough? And does users accept this channel via WhatsApp instead of a specified app? So just one little deep dive. Why is this RAG important? Why don't we just say, use ChatGPT? Why do we need actually something on top of this when ChatGPT is around? The problem is the context. So when somebody would ask ChatGPT how to build a toilet, ChatGPT would bring something like this, right? You need a basin, you need a tank, you need a flush, hole in the floor. But this does not match the context where the people live in, right? A real answer should look like this: local materials, local design, with the knowledge they have. So this is why we need to put this RAG architecture on top of the general purpose LLMs. Why is WhatsApp important? So why did we say we don't go this way with standalone apps? What we found in Uganda, and I think it's not unique for Uganda, is that many people are reluctant to install new apps. Yeah, for which reasons? Limited storage on the devices, data costs, and overall low digital literacy to learn how to use new apps. And then we found, WhatsApp is actually on every smartphone in Uganda. There's even in the most rural area, somewhere in the nowhere, people have smartphones with WhatsApp. And people, even if there are like elderly people not familiar to technology at all, everybody knows how to use WhatsApp. So we say, okay, if we can leverage this channel, we have an enormous increase in spread of the app. So we try to validate these two new ideas or approaches. For the quality, we did expert ratings. I will go into detail later. And for the acceptance, we did a community acceptance survey right at the boreholes where people collect their water in public boreholes. So this is how our artifact looked like. So you basically see a WhatsApp screen, right? This application was available with a local Ugandan phone number. So you could just save this phone number in your contacts and you can start chat with this solution. So we did some privacy protection notice and so on. And this is the architecture we used in the background. There is no rocket science inside there, right? This is very, very basic technical architecture. Why? Because this must be maintained by local people in Uganda. Yeah. So there was no reason to make this somehow fancy. So we tried to use like free services, free APIs, very easy, simple. I think the overall application is not more than 150 lines of code. Yeah, it's pretty small. So the focus is on the actual idea of using WhatsApp and RAG. And then we wanted to evaluate if this solution does reach the necessary quality metrics. And how we did this, we looked for questions which people would ask to WASH officers. Like WASH officers are people who work for the WHO, come to these areas and try to improve the facilities there. So we looked for job interview questions, which prospective WASH officers must be able to answer if they want to have this job. Yeah, we found like 5 sources. We looked for duplicates, deleted them. We looked for only open-ended questions. And then we feeded these questions to our chatbot and got the answers. So we had like 93 question and answer pairs. And then we gave this question answer pairs to 4 WASH experts, like from Uganda, Germany, and United States. So we tried to make it like culturally broad and ask them to assess whether the answer the chatbot gave is either perfect, which means like correct, and sufficiently explained. This is important, right? We want to explain to people why the answer is like this or not the other thing. Or it's sufficient, which means it's correct, but the explanation is kind of missing. Or it's not sufficient, which means like it's not wrong, but it's will not be as helpful as it could be, or it's actually wrong. And the answer of the expert shows that 86% of the answers the chatbot gave is perfect or sufficient. And this seems like not much, but if you think of the very specific context that people live in, right? We don't have much large language models which are trained on the context of somewhere in the deep forest where people have real problems with water access. Yeah, this is actually not bad. And also interestingly, out of 11 questions which were rated as wrong, 10 of these came from the one same expert. The other experts rated the same answer as perfectly or sufficiently, which one expert was rating as wrong. This was, by the way, the German expert, but it was not me, no worries. So there is some like disagreement here. But important is actually the answers are contextualized and sufficiently correct. So what we did afterwards, we went out to the field. We went to the public boreholes where these people collect their water in their jerry cans. And then we gave them like a smartphone. We let them talk to this chatbot via WhatsApp. And then we gave them a small questionnaire, technology acceptance model-based questionnaire to assess their experience. So we collected 77 responses. This was basically above the level we needed because we did a power analysis beforehand. And after like some cleaning, we remained with 71 valid answers. And this is basically the result. Usefulness, ease of use, intentional use is all way above 4. So the reception was actually kind of positive. So here are the other numbers, but they're not too much important because we are not confirming this structure equation model. We just put these numbers here to show that the items itself worked out. They are reliable. And we could see that people are really ready to accept it and would have the intention to use it. Yeah, and these numbers would be way lower if they would need to install an app firsthand. And we could also see this in the qualitative feedback we got on the field. Yeah, so people gave positive signals in terms of they repeated the importance of the needs they have. They really appreciated that we went out there and showed them this application and gave them this free
Sorry
service.
to interrupt,
And yeah,
but you have only 1 minute left for your
okay,
presentation to
it's fine,
conclude.
but I'm almost done. It's not a problem. Interestingly, we were also confronted with like this really low digital literacy because there were some users who even confused WhatsApp, like our application, with WhatsApp itself and could not distinguish between the two. So there is some work to go on. So basically, the artifact was deployed. We showed the quality in terms of answers. We showed that people are ready to accept this channel, not via a standalone app, but via WhatsApp. And this is the basis we want to continue to work on to increase knowledge base, also to include more local languages, because this was English only. We experimented with Luganda. We also experimented with like voice messages, yeah, because many people can't write and read. This is a real issue. But for this evaluation, we just used English text-based to make it like better comparable. And here we go, references. Thank you for your kind attention, and I'm very open to questions and feedback.
Thank you, Simon. Do we have any questions for Simon?
No, I don't have any questions. Simon, it's really nice presentation, and trust me, I have a word for you that you're really doing something good for the society. And it is really
Thank you.
required, it's really required because people are struggling a lot. And if we are developing such kind of applications and models, it will really very good for the sustainable development goals as well as to the teachers and all the human beings that's required. Thank you so much for your presentation.
Thank you very much.
I'm really happy that you presented at this conference, and I believe my friend Firaz also agree on the same line. Right? Thank you so much.
Thank you very much.
Thank you very much, Dr. Simon, about your interesting presentation. I would like to ask about how do you evaluate the factual reliability of the generated responses? And another question, could your framework be adapted to other public health applications or just for this application?
So the first question, the reliability of my constructs. So I used a pre-validated questionnaire, right? I used the very common technology acceptance model. And what I showed here is the Cronbach's alpha value for the constructs, which is all phi and above 0.7, which is a lot given only like 71 responses, right? And we also see that the assumptions within the models, they're holding. So I did a very easy correlation between the perceived usefulness and intention to use, and also between ease of use and intention to use. They are both highly correlated. This is not too much important for us because I'm not checking the internal consistency of this structural equation model, right? If I would do this, I would need also check for common method bias and all the other things. So I used a pre-validated questionnaire just to make sure that the answers I can rely on. Yeah. And so these measures here, they just show that obviously the pre-validated questionnaire is working correctly as expected because all the effects which we expect we could see. And the internal consistency between the items is way above the thresholds we need. Yeah. So basically interesting is this one here. And this is especially interesting if you compare it to the standard deviation. So we see, for example, here, we have like 4.36, the average, yeah, on a Likert scale from 1 to 5, yeah, and a standard deviation of almost 1, so which would reach like even ceiling effects on 5, yeah, and still we get like the full internal consistency, which is not like standard. It just shows that obviously after cleaning, because we removed like 6 answers, which I said here, yeah, people seem to accept this questionnaire and were able to understand what it's actually asking for, and we can rely on these answers.
And is it adapted to other
sorry, I forgot this
health
question.
application?
Yeah. Basically, the architecture is really simple, and the only thing you need to do to change it to another application is to change the knowledge base. Yeah, so this one has now like 6 or 7 PDF files from WHO and from Uganda organizations, which are talking about this thing. And I could easily change the knowledge base to other documents. And this is what we did because we have a similar application which we serve to teachers in Ugandan secondary schools, which is able to give them like pre-configured lesson plans. They have like major issues with curriculum changes there. So the contribution is not in the architecture. It's really simple. Yeah, the contribution is in this idea of using WhatsApp as a channel to increase the spread of the information, which would not be possible like this if you use a standalone app.
Thank you very much, and congratulations on this valuable contribution. Thank you.
Okay, thank you very much as well. Any other questions?
No, just want to update Simon. The same model I had also worked in India for the development of education in the school level children, right? And that's really working because it's already available thing. We are just adding something, and we can change. That's not
exactly.
That's a remarkable thing. Even I'm very happy because you also did it on the same way. That's why I'm very happy. Thank you so much for that.
Exactly. But as you said, the architecture is not rocket science. The architecture is pretty simple. The contribution is in the way to deploy it.
Yes, that's important. That's important. So thank you so much for your presentation, Simon, and I think I'll hand over the session to the session coordinator. Samriddhi, are you there?
Thank you. Yes, thank you so much. Sorry for the inconvenience. As we come to the end of this technical session, I would like to sincerely thank our authors for their excellent presentation and valuable contribution. I also extend my heartfelt gratitude to all the participants for being a part of this international conference. I hope today's session has been informative, engaging, and enriching for everyone. On behalf of the entire team, we thank you for your continued support World S4 2026, as well as throughout the previous 9 editions of the conference. We look forward to welcoming you again to the 11th edition in 2027. All presenters will receive their digital certifications via email within 2 working days. The conference publication will be available within 7 to 8 months. We kindly request your cooperation with the World S4 2026 team throughout the publication process. I would also like to I would also like to express my sincere appreciation to our session chairs, Dr. Firaz Shaukat Hamid, sir, and Dr. R.K. Taylor, sir, for successfully chairing this technical session. On behalf of Team World S4 2026 Global Knowledge Research Foundation and our partners, please as a token of our appreciation for your valuable support and contribution. Thank you once again for your valuable presence and participation. This concludes our session. Before we end, I kindly request everyone to switch on their cameras for a quick group snapshot for our virtual conference.
Thank you very much.
I request you all to please switch on your cameras. Stay safe, take care, and have a wonderful day ahead. You
Thank
can
you
leave
so
the
much
meeting.
for connecting and presenting your papers. Yeah, bye-bye.
Thank you very much. Bye bye.